welcome to my YouTube channel. My YouTube channel name is MS Maths. Today I am starting a new chapter in mathematics of class 9. The chapter name is number system. So how many of you are aware of this number system here? So in number system, first we learn about natural numbers. What are natural numbers? The counting numbers are called as natural numbers. All these numbers comes from nature itself. That's why that set is denoted by natural numbers. These natural numbers are denoted by n. So the set of counting numbers are called as natural numbers. So we denote this collection by capital N. So the set of natural numbers are 1, 2, 3, 4 and so on. Here the least natural number is 1 and there is no greatest natural number, and every natural number has a successor and every natural number has predecessor except 1. So this one has no predecessor, children. Okay, so we can represent these natural numbers on the number line. So here I have drawn a line here. So on this number line I mark some points at equal distances, children. So I name them as 1, 2, 3, 4, 5 like this. So I can represent every natural number on this number line, children. Suppose, so every man has always a need. Because of this his needs, so we try to extend our number system, children. So before that we have only natural numbers only. Suppose I have 3 chocolates and I gave these 3 chocolates to 3 children. Now how many chocolates left with me? Actually, how many chocolates I have, children? 3 chocolates. I distribute all those 3 chocolates to 3 children. So how many chocolates left with now? So I have nothing left with me, children. So to show this nothing, we use a symbol. So we call that symbol as a 0. So with the introduction of this 0, we have a new number system. So that we call that collection as whole numbers. We call that collection as whole numbers. What are whole numbers? So the collection of natural numbers together with 0 is called whole numbers. So the set of whole numbers are denoted by W, capital W, children. So what are whole numbers? 0, 1, 2, 3 and so on. So here the least whole number is 0 here, and there is no greatest whole number, and every whole number has a successor and every whole number has a predecessor except 0. And we can represent these whole numbers also on the number line, children. So here I have drawn a line. On that line I mark points at equal distances, children. So here I have marked some points here. So 0, 1, 2, 3, 4, 5. So like this I used to represent all the whole numbers on this number line, children. So I told already, as the needs are increasing, so thereby we are extending our number system. Suppose, so if I ask you subtract 3 from 5, when I ask you subtract 3 from 5, what you will do, children? You try to do like this. 5 minus 3 is equal to 2. Suppose if I ask you subtract 5 from 3, so how we write that one? Subtract 5 from 3. How we write? We write that one as a 3 minus 5. What is this? So we don't know. So that's why there is a need to extend our number system. So with the now just we have only natural numbers and whole numbers. So that's why there is a need to extend our number system, children. So the collection of natural numbers, 0 and negative of natural numbers. Negative of natural numbers is called integers. We call that collection as integers. The set of integers are denoted by I or Z. The set of integers are denoted by I or Z. So integers I or Z. So what are integers here? -3, -2, -1, 0, 1, 2, 3, so on. So these integers are also called as directed numbers. We call them as directed numbers. Directed numbers. Because they have direction. These integers have a direction, children. So we call them as directed numbers also. And see, in natural numbers it starts with n. That's why it is denoted by n. Whole number starts with w. It is denoted by w. In integers it starts with I. That's why it is denoted by I. Then why z, sir? So why it is denoted by I or z, sir? So this z is the first letter of the German word. First letter of the German word Zahlen. So the meaning of Zahlen is to count the number. To count the number. So Z is the first letter of the German word. The first letter of the German word Zahlen. The meaning of Zahl means to count the number. So that's why the set of integers are denoted by I or Z. So what are integers, children? The collection of natural numbers, 0 and negative of natural numbers. Negative of natural numbers is called as integers. These integers are also called as directed numbers because they have direction. So the direction is either positive or negative. So they have direction also. So we can represent these integers also on the number line. So here I have drawn a number line here. On that number line, first I mark 0 here. From this point at equal distances, I mark some numbers here. So this is 1, 2, 3, -1, -2, -3. So this is 1, this point is 2, this is 3, this is -1, this is -2, this is -3. So like this we represent every integer. Even this is 0. We can easily represent all these integers on the number line. So on number line, as you move from left to right, its value is keep on increasing. As you move from right to left, its value is decreasing, children. Okay. So all natural numbers are whole numbers and all whole numbers are integers. So natural numbers are subset of whole numbers. Whole numbers are subset of integers. Okay. So suppose if I ask you, so I told already, as there is a need, so we try to extend our number system, children. So here if I ask you, let us divide 4 with 2. So what you get to answer? The quotient is 2. Suppose if I ask you, let us divide 3 with 4. And I ask you, let us divide 3 with 4. So what will be the quotient? You get the quotient as a 3 by 4. So we don't have such numbers. So that's why there is a need to extend our number system. So up to now we have only natural numbers, whole numbers and integers, and we learn how to represent natural numbers on the number line, whole numbers on the number line, and also integers on the number line. Now we learn about, so we are extending this our number system. So the new system we call that one as a rational numbers. So what are these rational numbers? Here what I am doing here, I try to find the ratio of 3 and 4. Here I am trying to find the ratio of 3 and 4. Thereby I am getting the quotient as 3 by 4 children. So that's why this system is known as rational numbers. So what are rational numbers? So the definition of irrational numbers is these rational numbers are denoted by the letter Q. So why it is denoted by Q? So this symbol Q, the letter Q comes from, what is this? Here 3 by 4 is a quotient children. So the letter Q comes from the word, the first letter of the word quotient. So in that the first letter is Q. That's why these rational numbers are denoted by the symbol Q. And why this system is named as rational numbers? Because here I am trying to find the ratio of two integers. So the word rational comes from the word. What is that word? Ratio. The word rational comes from the word ratio. So that's why the system is named as rational numbers, and that one is denoted by the symbol Q, since this Q comes from the word quotient. So what are rational numbers? A number which is in the form of P by Q. A number which is in the form of P by Q, where Q not equal to 0 and P comma Q are integers. So what are rational numbers? A number which is in the form of P by Q, where Q not equal to 0 and P comma Q are integers. So we call that collection as rational numbers. So every natural number is a rational number, every whole number is a rational number, every integer is a rational number. But every whole number need not be a natural number. Every integer need not be a whole number or a natural number. Every rational number need not be a natural number or whole number or a integer children. And we can represent these rational numbers also on the number line, because just now we have seen on integers how to represent integers on the number line. So first we draw a number line. On that line I mark a point 0. From that point at equal distances I mark some points here, and I name them as 1, 2, 3, minus 1, minus 2, minus 3. So here I try to mark all the points, whatever numbers I want, I can represent them on the number line. So now I am taking a mirror and I observe this number line through that mirror. So here I am observing there are so many points which are not marked on this number line. So that means between any two integers there exists infinite number of rational numbers on this number line. Okay, so we call such numbers as rational numbers. Okay, a number which is in the form of P by Q, where Q not equal to 0 and P comma Q are integers, is called rational numbers. The word rational comes from the word ratio. These rational numbers are denoted by Q because since this Q comes from the word quotient. Okay, so we can represent every rational number on the number line. So let us take one example how to represent 2 by 3 on the number line. So represent 2 by 3 on the number line. So here what I am doing here, so here I have drawn a number line here. So this is 0. From that point I mark the points at equal distances here. So this 2 by 3 is a proper fraction since its numerator is less than the denominator here. Here what is denominator here? 3. So I am dividing each unit into how many equal parts? 3 equal parts. 1, 2 and this is third equal part. And again between 1 and 2 also. 1, 2, 3. And since this 2 by 3 is a proper fraction, its value lies between 0 and 1. Now I want to represent this 2 by 3 on this number line. So this is 1 by 3 and this one is 2 by 3. So it represents 2 by 3 on the number line. So like this we represent this rational number on the number line. So like this we can represent so many rational numbers on the number line. So between any two integers there exists infinite number of rational numbers. So if A and B are any two integers there exists infinite number of rational numbers between them. Now a rational number between A and B is a rational number between A and B is A plus B by 2. So A plus B by 2 is a rational number lying between A and B. We can do it by mean method. Like this we can write so many infinite number of rational numbers between A and B. So we will continue our class in the next class, children. So I am ending this section with the introduction of number system up to rational. So we will continue in our next video. So my YouTube channel name is MS Max. So every one of you please subscribe my channel. So thank you everyone.